founders of Science Rocks, our award-winning multimedia science project that encourages people to get excited about science.
And this is our story.
Today we're going to tell you about what we've done since we launched in 2013. We're going to tell you about our mission and show you how our films can help pupils and science teachers. We'll show you some of our award-winning films, and finally we'll tell you about our plans for the future. But first, this is Science Rocks.
Hi, I'm Tim Peake, an astronaut with the European Space Agency. This is Science Rocks.
So, how did Science Rocks start? Like most things, by accident. I made a video for my homework on plate tectonics. It was very simple. I wrote a script, read it out sitting in front of a volcano documentary, and filmed it on an iPad. That was it. Our mum decided to enter Megan's film into the Rock Watch competition. This is the junior department for the Geologists Association. I won third prize in the under 16 section. The next day, my dad had me put the film on Facebook. Science Rocks was born. And in 14 days it had been seen in over 40 countries. At the time we had only just turned 13. From then on we made more films, but we had no real direction. We were just doing this for fun. But then we were encouraged to enter our project into the South East England Big Bang. That was a fantastic day. We won 4 awards. Here they are. We were on our way to the finals with a very helpful piece of advice from one of the judges. We were now going to make videos about the GCSE science syllabus. Here's one of our award-winning films, Refraction. Where are all the fish? It won Best Physics Film at the NPL School Science Film Competition in 2014.
Today we will be talking about refraction and answering one of life's most important questions. Just exactly where are all the fish? But to do that we need to understand refraction. Refraction is the change in direction of a wave as it passes from one medium to another. Let's have a look at this pencil. We are seeing it through air and glass. Now let's add some water. The light reflecting from the bottom half of the cup now has to pass through water, which makes the pencil appear bent. This diagram explains the science. Light travels in a straight line until it hits a new medium. When it hits a new medium, the light is refracted and the angle of the light changes, although it still travels in a straight line. This will happen again when it hits another new medium. But what has this got to do with fish? If you're looking straight down at something through two media, e.g. water and air, then the light is not refracted. But if you're looking at something at an angle, the light will be refracted, and the thing you think you're looking at will not be exactly where you think it is. This is very important for spear fishermen in the Amazon. Being a good spear fisherman is not about how accurate you are, but how good you are at just missing what you think you're looking at. In other words, you're more likely to eat if your aim is a bit off. Refraction doesn't just happen between air and water. It happens when light passes through space into our atmosphere. Light takes 8 minutes to travel from the sun to the Earth's surface. Earth is always spinning relative to the sun. This is why the sun appears to move across the sky, but the sun is always 8 minutes ahead of our view. Don't forget refraction. The light has changed direction when it passes from space into our atmosphere. So now when you're having a walk in the park and somebody asks where the sun is, you can be a bit more precise with your answer. So, where exactly are all the fish? Not quite where you think they are. This is Science Rocks.
We had great fun at the finals. We made fantastic contacts and trust me, we really got noticed. One of the judges spoke to us the day after the finals. Our project was the one all the judges were talking about. We have since worked with some of the country's leading scientists. We've interviewed them and learnt about their research. And we've since had offers to talk at various events around the country. Probably our most important collaboration is working with the STEMettes. They've been here too. In the summer last year, we were invited to showcase our project as part of the launch of the STEMettes Outbox Incubator, a brilliant opportunity for teenage girls to work together in developing their STEM-based projects. As part of the launch, we presented our project to HRH Princess Anne as patron of women in science and engineering. We'll show you what we told her in a moment, but first, another film with a serious message about last-minute revision.
What are you doing?
Shh! Revising!
It's the middle of the night.
Shh! I know!
You have to get to sleep. You've got a test tomorrow.
Shh!
Cramming isn't the answer.
Shh! Yes, it is!
This isn't going to help.
Yes, it will! Go away! Shh!
You should have used spacing.
Go on then, Mr. Smarty Pants Revision Police. What is spacing?
Spacing is the exact opposite of cramming. Instead of leaving your revision until the night before, you should learn your facts gradually over a number of days or weeks.
How does that help?
The facts will gradually move from your short-term to your long-term memory. There they will be more useful.
So, how do I do it?
First of all, you don't leave it all until the night before. Learn your facts and test yourself. Then, a few days later, do the same again and repeat this gradually over a few weeks or months.
And that really works?
Yes. Remember those end of topic tests you did?
Yes.
And those half-year tests and the end-of-year tests? All of the revision for that was spacing. If you do a good job of revising for those tests, you will have taken the knowledge in from your short-term to your long-term memory.
It's just hours before the exam. What do I do?
The best thing you can do now is go to sleep. You did well in all those tests. You probably have a lot of the knowledge in your long-term memory already, but it won't be retrievable if you are too tired to think in the morning.
Rocks is unique. We are teenagers, and like any other teenager, we have an attention span of approximately 3.5 to 4 minutes. If you don't believe us, ask the music industry. We're also motivated by anything different and funny, but mainly it has to be short. There are lots of science films out there, but they're just too long, too slow, and too boring. If they were short, fun, and full of useful facts, we'd be using them ourselves instead of making our own. Our series of films on photosynthesis is less than 20 minutes long and made up of 4 separate films. We can't always inject humour, but we try to be different. Our first film in the series was shot in a vineyard in Dorking, and when we made our film on identifying salts, we did it in the style of a CSI programme. Sometimes we make our films like a news bulletin. By constantly changing, we're keeping it fresh, whilst also making sure we get the facts across. Our films have had over 10,000 views, and this is just by word of mouth. Our films serve 3 purposes. Firstly, we actually use the script writing and filmmaking process to help us revise. It works. Secondly, we want to make and share short science films crammed with facts. And thirdly, our films encourage more pupils to get interested in science. Let's tell you what we did at the Outbox Incubator. The STEMettes are brilliant. A group of female scientists that want to encourage more girls into STEM. In the summer, they held their first Outbox Incubator. We took part for 2 weeks and developed our project under the guidance of some brilliant mentors. But we were also invited to the launch party. This is what we presented.
We are Science Rocks, and we want to inspire more girls to get excited about science and hopefully have great STEM careers. There are lots of organisations out there that want to help undergraduates stay in science, but if we want to have female undergraduates in STEM, we need to tackle the problem at the base. A report published by the Sutton Trust highlighted the number of schools where the only option is double science. In other words, triple science is either not offered or not selected. The results were alarming. In the Midlands, 80% of schools taught triple science. In Kent, the percentage fell to 73%, and in Medway, the figure fell to 65%. In other words, 1 in 3 schools didn't offer triple science. There may be legitimate reasons why triple science is not available, but regardless of the reason, if triple science isn't taken up, the likelihood of going on to study science at A-level is reduced, and then you are unlikely to study science or engineering at university. Just think about all the doors you are closing before you've even finished being a teenager. The lack of scientists and engineers is a real problem. Current estimates indicate that we have a shortfall of 2 million scientists and engineers. Women in Science and Engineering, or WISE, wants to make sure that at least half of them are women, and so do we. That is a huge number. This is Miriam. She is a physics undergraduate. She won the bronze medal in the Big Bang 2013 for her work on researching prostate cancer. She wants to be a research scientist. She is a brilliant science communicator, and through her work with women in physics, she is encouraging undergraduates to remain as scientists when they graduate. But, like we said, without triple science at GCSE, you are not going to get science undergraduates at university. This is why Science Rocks wants to encourage teenagers to do triple science and stay interested in science. We think science is brilliant, and we think great scientists are awesome, and it's not just for boys. We are girls. We are Science Rocks. Deal with it.
And now we're up to date. Science Rocks is 2.5 years old. Each year we host a lecture at our school. If you're local to Sutton, please find us on Facebook and come along. We have some excellent speakers, including Anne-Marie and Mephiza from the STEMettes and Dr. Simon Foster from Imperial. We showcase our project at science events, and each summer we try to do 2 to 3 lectures at junior schools for year 5 and 6 pupils. We have a fun show with lots of interaction and volunteering. We use some of our films and we have lots of live experiments. If you're a junior school teacher in the Surrey-Sussex area and want to invite us to your school, please see us afterwards. We are followed by some of the UK's greatest science institutions and leading scientists on Twitter. Scientists and science students at all levels from across the globe follow us on Facebook, and it is great to have their support. We know a group of scientists in Washington DC who use our films in science-themed birthday parties, and a South African charity uses our films to help teach children who have lost both parents through AIDS. And at schools across the UK, junior and senior school teachers use our films to teach, and students use them for revision. Here is another one of our award-winning films.
What is the difference between fuel and energy? Fuel is a substance like oil. Energy is locked in its chemical bonds and is released when the bonds are broken. Today we are going to look at the energy released when hydrogen and oxygen combine to make water. If this was an uncontrolled reaction, there would be an explosion or pop, but we are going to do a controlled reaction, so no pop. Hydrogen and oxygen gas are kept in separate tanks. The gases are fed into the fuel cell where the two gases are separated by a membrane. This fuel cell has an anode, a cathode and an electrolyte. At the anode, hydrogen gas becomes hydrogen ions and diffuses through the membrane. At the cathode, the H+ reacts with oxygen and gains electrons to produce water. This happens because electrons move from the anode to the cathode, creating an electric current. Water can be converted back into its component gases. This is electrolysis, but this process requires energy. So that's the science, and here's the demonstration. You can see the two gas tanks, one containing hydrogen and one containing oxygen. all wired up and ready to go. Time to test it on our Mars simulator. So there you have it. Hydrogen and oxygen are fuels which combine to release energy. Chemical energy is released and electric current is created, and this provides the usable energy to move our car on Mars. This is Science Rocks.
We are at the dawn of a new era for science and technology. Teachers, please use Science Rocks as a resource of short science films to teach years 8 and 9 upwards. There is no subscription fee and no advertising. Just short films on mini topics you can easily slot into your lessons. We even have a section called Just for Fun, which is ideal for junior school pupils. Imagine, over 100 films made by teenagers for teenagers to show that science is fun. We want to encourage more people to enjoy STEM careers. We want more people to study STEM and have great jobs as scientists and engineers. We'll keep making films and showcasing our project. My plan is to go on to university and possibly study engineering or science and communication. I plan to become a large animal vet. Just one last film before we go, and just to prove it's not all hard work and script writing, here's a bit of fun. We made this one Saturday afternoon while driving around looking for locations. Thank you. This is Science Rocks.